We clean our coils every year. And you're saying that a blue light with invisible UVC rays will clean the coil year-round, improve thermal comfort, and save 10 to 20% of our AC energy costs? Get out of here.
The purpose of the evaporator, or cooling coil, is to provide thermal comfort in a building by removing the humidity and heat from the building's air. The cooled and dried air is circulated around the building by a large fan and is then sucked back to the air handler along with the warm and humid byproducts from the people in the building. A percentage of fresh air is then added. This mixed air is passed through the primary filters to remove big dirt particulates. The resulting condensate in the cooling coil is drained away to the sewer. The heat from the building's air is absorbed through the coil fins by a cold liquid, typically chilled water, that is being pumped through the coil. The heat is then transported in the water back to the chiller. The chiller has a compressor that initially squeezes gas, turning it into a liquid, that then passes through an expansion valve, returning it back to gas and making it cold. The cold refrigerant gas absorbs the heat being carried in the water coming from the cooling coil. This chilled water is then returned to the coil. There is a separate water circuit that collects and removes the heat absorbed by the compressor's gas, which is then sent to either a condenser coil or cooling tower. In either case, the heat is transferred from the water into the air, and the resulting cooled water is pumped back to the chiller. The metal fins of the coil are typically made of aluminum that has a heat transfer efficiency of 200 watts per meter Kelvin, whereas the biofilm that often covers the fins may be 0.2 watts per meter Kelvin, or approximately 1,000 times less efficient. According to the California Society for Healthcare Engineering, it only requires a 1.5 millimeter fouling on the coil fins, 0.006 of an inch, to reduce the coil's efficiency by 16%. When particulates pass through the primary filters and settle on the coil, we should expect the condensate that is produced when the warm air meets the cold coil to wash the particulates down into the drain pan, as easily as one washes mud off a car. But the dust stays on the coil and often requires harmful chemicals to remove it. We now know that as soon as the condensate is produced, mold and biofilm start growing. Mold takes 4 to 6 hours to double, so it can easily multiply into 1 billion organisms in 12 days. As long as it's alive, it will cling to the coil fin. Its sticky surface attracts and grips the dirt, forming the biofilm. The biofilm reduces the heat transfer function of the coil, and consequently the air is not cooled sufficiently, nor is the humidity removed. To achieve the desired thermal comfort, either the occupants alter the thermostats, or the maintenance department adjusts the chiller set point. In either case, this increases the electrical consumption of the chiller and pumps. In a typical office building, the AC system uses 60% of the building's energy, and of this, the chiller and pumps consume 70%. The 2006 ASHRAE published study estimated savings of 15 to 30% from clean coils. SterilAire's emitters continuously clean the coil fins by destroying the DNA inside the microbes. Once the DNA is destroyed, the microbe can neither grow nor duplicate, so it dies. The dead mold falls away with the dirt and is washed by the condensate into the drain pan. Whatever your industry, you can benefit from SterilAire. Save 10 to 20% of the AC energy cost and increase your profits. Call your local SterilAire distributor or contact us via phone, email, or the web.